What about 7? Did you want to work?
That does what?
It's an analog computer. So all it does is sum numbers, which is what an analog computer does. So when I was asking that, I was thinking, oh, it's asking for something more specific. It's really just summing. Draw the next one up there. Oops. These are both reversed. So I went ahead and wrote problem 7 up there. Now we look at it, first thing I'm going to note is my battery polarity. And we want to know the voltage V compared to ground down here. Which might seem a little backwards to us on some of those, but really since the batteries are running either direction. So if I look at the current here, it's flowing out in all directions. This current is going to be V minus 4 volts, all divided by 1.2 kiloohms. Is it okay if I go ahead and skip units? Now, if I divide by kiloohms, I would get milliamps out of this, but we're just going for volts anyways. Plus V minus 9. So this is actually be plus 9 because of polarity, 27, plus V and plus 3 volts in white over 2.2. Now that I wrote this down, I can find a common denominator and multiply it through. So I'll just note that 1.2 times 27 times 2.2 is 71.28. So I'm going to come down here, I'm going to multiply by 71.28. So that's 59.4 V minus 59.4 times 4 is 237.6. Divide this by this, and I have 2.64 V plus 9 times 2.64 is 23.76 plus 71.28 divided by 2.2 gives me 32.4. So 32.4 times V plus 3 times 32.4 is 97.2. Now I did that in one step, so I want to make sure you're good with how I got there. I came through and just said, I've got these denominators. I don't know what to do with them, so I'm going to multiply them together because I know that'll give me a common denominator. 71.28. I take 71.28 times everything in here. So that means in each step, you're just going to divide by that denominator, whatever is left is what I'm going to multiply that numerator on top. So now if I go 59.4 plus 2.64 plus 32.4, I end up with 94.44 V I take 237.6 negative plus 23.76 plus 97.2, I'm left with minus 116.64. So done, V is going to equal, move that over, 116.64 divided by 94.44. Equals 1.235 volts.
That one was a big, it's mostly just dealing with all the polarities. How does that work out? And then you get funky numbers in this case. I know in problem 6, I say use Millman's theorem, but we haven't introduced it yet. You can still use your nodal voltages. So if I want to do 8, really I just want to draw a schematic. And dear Lord, are those tiny.
It might be a little bit easier to, I might have been able to get a little bit of progress on number 8 if I were able to read the numbers on the batteries. Because unfortunately,
I think it's 10 point. Did you try online expanding them?